Okay. So looking at this is a table question. So the cool thing about table questions is those are the only numbers you can use. But you said 1D. So the density of bacteria in a petri dish between 1 and 4 is modeled by the graph function. Okay, they give us this fugly equation. For what values of k between 1 and 4 is k equal to the average of r between 1 and 4? So real quickly, Haruka, how do I find the average? Do you know the average?
Average value, you can either do like 1 over b minus a integral of a to b of f of x dx, or you can do f of b minus f of a over b minus a.
Right. So for this average value, that means it's the integral one, right? If it's average rate, it's a b minus a. Cool. So that's why it's average value. So average value is, and that's like the trick words. They're both, the word is average. The average, when I find the average GPA, you add up all your GPAs. If you just average rate, you just find the last rate, the last value, first value, and divide by b minus a. So in this case, it's just 1 over 4 minus 1, and then the integral from 1 to 4 of this equation. And again, this is one of those points where I say it's like a keyword type of question. And if you just like spent, like if you weren't nervous and this was just a problem that you're just challenging yourself with, and it wasn't a test, you'd be like, oh, average rate. No, it's not average rate, it's average value. So we would just do that. Okay. And then, so the density is modeled by G for what values of K is it equal to. So then once we have this answer, this is going to be some answer. On our graphing calculator, we could graph the graph G of R, and then we can make that equal to this average here. Okay. Okay, again, just reading again, the density of bacteria, blah, blah, blah. This is just filler modeled by the equation. Okay, that's the average density. So what values of K is the average value of R? Yeah. Yep. Okay. Then Nelly, are you okay with that? Or do you need me to rephrase it? Okay. Let's see. Haruka, do you want me to graph it and show where they equal to each other?
Sure, so that I can make sure I'm doing this correctly too on my graphing calculator.
Cool. All right. So if you want to graph, I'm just gonna use Desmos because it's a little faster here. Oh, I need to use my graphing calculator too because I need to figure out what the integral is. So, okay, real quick, I'm gonna take the integral. So we're gonna go, we'll do the average, but I'm gonna do the average. I'm gonna actually do the integral first because I can mess up that. Math 9, and then we're going from 1 to 4, and we're doing 2 minus 16 parentheses cosine of 1.57 second radical x close. Oops. I'm going to stick this to the third dx. Okay. Then we're going to divide this by 3 because 4 minus 1 is 3. So I'm getting the number is 12.238 as my average. Oh no, I should have typed it as my y function. That would save me a lot of time. Okay, darn it. Okay, let's go ahead and do that. Actually, you know what? I wonder if we can just copy this function. No, I can't copy it. Okay, we're going to graph the graph 2 minus 16 cosine of 1.57 square root of x, close it, and then close it to the third power. Okay, and then so we're looking for when does that answer become this value here. I'm going to actually store this in A. Oops. Enter, store in letter A, alpha A. Let's see if it works. Bad. Okay. Uh-oh, this looks not good. We know that they're going to run into each other between 1 and 4. Let's set the window real quick. Window between 1 and 4. And we're going to go from 0 to, we said our value was 12. So let's do 13. Let's do 15. Let's see what that looks like. Oops. I was messed up on the window part. Y minimum is, it's going to be from 1 to 4. That's going to be 1, let's do 12. 12 to 15. Just to make it really clear. Okay, so I'm going to hit second calc and find an intersect. First curve, second curve, and then make a guess. It's close enough. I'm getting 2.7625.
Mr. Ko, I got like a different answer for the integral. I don't know why.
Um, is my answer right or wrong? Do you know what the answers are?
No, that's why I was like asking.
Darn it. So my answer is wrong, right?
I don't know. I just checked a bunch of times if I like typed it incorrectly.
Okay. So my integral, did you end up with 36 and then you divide it by 3?
Let me try to do it in a different way.
1 point. Oh shoot, I put the wrong number. Oh my gosh. Freaking idiot. I put 1 point. Oh my gosh. I put 1.75. It should be 1.57. Ah, gosh, then divide this by 3. Divide this by 3. Darn it. Okay, it's actually 9.87. Is that what you got?
Yeah.
Dang it. And then let me copy this one. I'm going to store this. Enter, store in A. And then we can look at that again. I'm going to set my window again from, let's say 9 to 10. Let's do that. And the answer, second calc. Second calc, we're going to find intersect, which is 5. Enter, enter, enter. 2.497.
Mine's really close, but it's a little different for me.
I wonder why it's different. Let me see. Oh, maybe it's because of the round off. You ended up with 9.8, right? So I just used the whole number, 9.8757948868. Maybe that's why it might be a little bit different. Let's see. Haruko, so this answer did not work, the 2.497.
I got 2.657.
I see too many variables, right? I see an X and a C. I'm like, oh my gosh, it's gonna be one of these questions. Okay, the company designed a spinning toy using a function y is equal to some crazy y, where C is a positive constant. Okay, C, just in the back of your brain, C is gonna be positive. So if C is positive, okay, the figure above shows the region of the first quadrant bounded by the x-axis and the graph. And that's the graph of cx square root for some value C. Each spinning toy is the same shape as a solid generated when the region is revolved around the x-axis. So I'm thinking this graph right here, this graph, when it's spun around the x-axis, looks something like that or something. Whatever, you get the idea. Okay. Oh shoot, it doesn't go up and it doesn't go in on itself. That's not going to be a function. Okay. And then the reverse will look like that because we're spinning around the x-axis. For both x and y are measured in inches. Okay, got it. And then which part do you need help with, A, B, or C?
B and C.
B and C. Okay, the hard ones. Yay. Because the first one was pretty easy. Got it. So it is known that for y is equal to blank, the derivative is blank. For a particular spinning toy, the radius of the cross section of the spinning toy slice is 1.2. Although, wait, the radius of the largest cross-sectional circular slice, something like that, is going to be 1.2 inches. What is the value of C for the spinning toy? Okay, so one thing we want to know is that we know that this value here, this equation is y is equal to cx square root of 4 minus x squared. Okay, I know that for sure. And then they told us that the radius of the largest cross-sectional circular slice, the radius is, so this value here is going to be 1.2 inches. Okay, what is the value C for the spinning toy? Now, we can plug the y in. So this is 1.2 is equal to cx square root of 4 minus x squared. Okay. That's the first thing I'm thinking. But I can't figure out what the C is and I can't figure out what the C is because there's too many variables. That's the first thing I'm stuck with. And that's why they gave us a second equation. Now, let me ask you, looking at this graph here, look at the graph here. We're increasing, right? And then we start to decrease right here. So what do you think happens at the largest point here? What is the slope? The slope is going to be, what do you think?
0.
0. So that's why they gave us the second equation. dy over dx is equal to c 4 minus 2x squared over square root of 4 minus x squared. They gave us the derivative, so we have to use the derivative. And I was thinking at the largest portion here, that slope's going to be 0. So we have 0 is equal to c 4 minus 2x squared all over the square root of 4 minus x squared. And then we can, if I multiply this over, I guess, maybe, we're trying to figure out what I can do to now solve for one variable. Now, we could try this. If I go ahead and solve for C here, I'm not sure this is going to work, but I'm changing. Maybe if I solve for C is equal to 1.2 over x square root of 4 minus x squared, okay? And if I substitute x in, if I substitute C for C, we only have a one variable equation then. So 0 is equal to 1.2 over x square root of 4 minus x squared, okay, times 4 minus 2x squared over the square root of 4 minus x squared. Are you okay with how I plugged in the C value?
Isn't C in the numerator or is
C, it is in the numerator, but it's like C over 1. So you could write it in the numerator, but if you remember, it's like c over 1 is the same as like, it's like 3 over 2 is the same as 3 over 1 times 1 over 2. So I just stuck the c here. But if not, it would look a little it would look a little funky, but fine. That's if you write it the other way, it would be 1.2 over x square root of 4 minus x squared, 4 minus 2x squared. Okay, let's write it this way, over the square root of oops, 4 minus x squared. We don't like dividing fractions, so we could multiply this by the reciprocal. So it's 1.2 over x square root of 4 minus x squared, 4 minus 2x squared, that's the top, multiplied by the reciprocal is 1 over the square root of 4 minus x squared. And this gives us the same thing that I wrote up here. Would that be okay, Haruka?
Yeah.
Cool. So the cool thing is that these two are the same now, right? So we have 1.2. They want us to find the value of c, but we can't find c till we find x, I feel. So we have 1.2 equals 0, 4 minus 2x squared all over x times 4 minus x squared. Let's see. When does this equal to 0? We just really worry about the top, I think. So it's 0 is equal to 1.2, 4 minus 2x squared. When does the top go to 0? The top goes to 0. I want to multiply that out. 4.8 minus 2.4x squared. Moving stuff over. That's going to be negative 4.8 divided by negative 2.4 is equal to x squared. This goes into 2 times. X squared, x equals to plus and minus 2. In this case, we only can be positive 2. Square root of 2. All right. So we know that going back that 1.2 is equal to c square root of, sorry, x square root of 4 minus x squared. We know what x is. So it's 1.2 equals to c square root of 2 square root of 4 minus square root of 2. Square root of 2 squared. Oh, that doesn't look good. Square root of 2 squared would be, square root of 2 squared would be just, oh, it would just be 2, right? Oh no, to be, yeah, it'd be 2. Square root of 4 minus 2 and have square root of 2, c, it's 1.2 is equal to c square root of 2 times square root of 2. Become just 2. So 2c equals to 1.2. C is equal to 0.6. And that's the value of c. Okay. Haruka, how we doing?
I actually did it correctly, which I'm happy about. But if like we're doing this whole thing and I can just leave it at like 1.2 divided by 2 instead of 0.6.
Yes.
Right?
Yeah. You don't have to do any of the actual math part. You could actually did this. You could say c is equal to 1.2 over square root of 2 square root of 4 plus square root of 2 squared. You could left like that. Right? Okay, so Haruka, real quick, what was the only calculus in this whole problem?
That dy over dx is equal to 0.
That's the only calculus in this whole problem. The rest was algebra 2. Okay, and that's the crappy part. That really was the only calculus in this whole problem. And I'm pretty sure, like, if you were able to set that equal to 0, that was already a point. And then if you solve for like x, that was probably another point. We can look up. I'm not sure if I can find the guide, but yeah, which is kind of dumb about this. But you're okay with this?
Yes.
And the one thing, remember how I said whenever I look at these AP questions, I just think about the basics, and that's legit what happened. I saw the graph, and the graph looked like a curve. I was like, okay, it's going to be at this max point, and the max point is going to be a critical point, and that's going to be 0. So I was able to first get stuck here. I need two variables. I can't solve them. In algebra 2, I learned I need two equations to solve for two variables. I had to use the second equation. The second equation, the dy dx was a 0, and then we had two variables that we could end up substituting in. Okay, and then the last one you need is part C, right? Let's work on that. For then another spinning toy, the volume is 2. Okay, for another spinning toy, the volume is 2 pi. Oh my gosh. Okay, what is the value of C for the spinning toy? Oh my goodness. Okay, so how do I find the volume? The volume is this shape that we're going to spin around the x-axis. So we have our toy spinning this way, right? We have a going there. So we know it's going to be circles. So this is a disk. So you have pi r squared, integral of pi r squared, because we're adding circles together. So it would be the pi. Now the problem is, what would, so, okay, we have 2 pi is equal to pi integral from 0 to, we don't even know the x value, 0 to x of cx square root of 4 minus x squared dx. And then we're going to square this, pi r squared, okay? So this is a non-calculator problem. For another spinning toy, the volume is 2 pi. Okay, 2 pi cubic. So that's the volume, and our volume equation is pi r squared for the spinning toy. What is the value of C for the spinning toy? Well, if I cancel out some stuff, 2 is equal to the integral from 0 to x of, I guess we have used it. We have to use a different value for that. 0 to, what would I call it? We would have to do, you change the value. So you be C, let's say t square root of 4 minus t squared dt.
Since it's
Okay, so if they ended up using x as 2, fine. If I put 2 there and put 2 there, this problem is a lot easier then. So it's 2 is equal to c squared integral from 0 to 2 of 4t squared minus 4t. Oh, yeah. But I guess we didn't need to change the variables anymore because it's not x anymore. Anyways, it'll be just 4 t cubed over q minus 4, so t to the 5 over 5, plug in 0 and 2. And then we have c squared equals to 2. And then we plug in 2, that'd be 8. 8 times 4 is 16. Oh, 8 times 4, yeah, sorry. 2 times 2 times 2 is 8 times 4 is 32 over 2 minus 232 over 5. And then the zeros don't matter. And then c squared. So it's 2 over this bunch of junk. It's over the square root of 32 over 2 minus 32 over 5. So they ended up with the answer of square root of 15 over 32. Oops, my my square root is wrong. Squared over everybody. We divide it and then we take the square root. Yeah, well, at least that's what they did. And if you want to find a like common denominator, that's going to be a 5 Sorry, this is a 3. 3. So if you leave this on your exam, you can do that. But if I try to get that, that's 5. 5 times 160 minus 96 is 64 over 15. So 64 over 2 over 64 over 15 multiplied by the reciprocal is 2 times 15 over 64. It's 15 over 32. So this is what they got on this one YouTube channel. Okay, find the area of the region first quadrant, but x is given the graph of that, and c is equal to 6. I wonder why they used 2 though for another spinning toy. Each spinning toy in the shape of a solid generated by the region that is revolved around the x-axis with both x and y measures in inches. Yeah, I don't know why they made that c value 2. Okay. Haruka, so if we decide to just take the cheap answer and just take it as 2, we are good. Oh, I see what they did. Oh, I see what they did. It's because when you try to solve x square root of 4 minus x squared, right? When does this graph equal to 0? There's only 2 places that this equals to 0. And the reason why is because it's 0 is equal to c times x times square root of 4 minus x squared. And so it's at 0, x equals to 0, and x equals to the square root of 4 minus x squared. So my first 0 is 0, and the second one is, sorry, that's equals to 0. That's equals to 2. That's why. So for regardless of the toy, it was always going to be 0 and 2 here. That's why they use 0 and 2. Okay, Haruka.
Yeah, I was a little confused on that.
Yeah, so they got the 2 is because they went ahead and said, hey, this graph can only be 0 at what places? At 0 and at 2. So no matter how you draw the graph, that's just what it is. So even if c changes, you're still stuck at 0 and 2. And that's why that's 2 there. Okay.